Hello students, in previous video we learned about some theory part of this chapter, right? In that we already seen three types of data, that means ungrouped data, discrete frequency distribution and continuous frequency distribution. So now in this video we will start our measures of central tendency, and first is mean. Okay, so first of all we learn about the mean. So first of all, arithmetic mean. Mean means what? One type of average, right? We find the average speed of our bike, right? Average marks in all the subjects, that means our percentage. So that is average, it is our arithmetic mean. Okay, so first of all, first type of data, it is for raw or ungrouped data. Ungrouped data, it is also called raw data. So here for raw or ungrouped data, what is the formula of mean? So mean x bar is equal to x1 plus x2 up to the xn divided by total n. Okay, here this formula we already learned in standard 7 and 8, right? That means sum of all the observation divided by total number of observation. Okay, so in numerator, sum of all the observation, it is called sigma x. X, that means our different observations. So sigma x divided by n, where sigma x is equal to sum of all observations divided by n, and that n, it is equal to number of observation. Okay, so if ungrouped data is given to you, then what you need to do for finding out the mean? First of all, in numerator, sum of all the observation, sum of all the numbers divided by total number of observations. Okay, the numbers which is given to you, it is called observations. Okay, then next type, it is for discrete frequency distribution, otherwise discontinuous frequency distribution. In that, one table is given to you, x and f. Here some values are given, 1, 2, 3, and frequency, that means 1 5 times, 2 maybe 7 times, 3 4 times. So this type of table given to you, and if you need to find the value of mean, okay, so you need to use this formula, mean x bar is equal to sigma fx divided by n. Here fx, that means multiplication of frequency and your observation x. Okay, so if this type of data is given to you, then first of all we need to find multiplication of f and x. Okay, it is called fx. So here multiplication of f and x, 5 1s are 5, 9 2s are 18, 4 3s are 12. Okay, and if you find the total of this column, it is called sigma fx. Okay, you need to find this answer and we need to put this answer in our formula. Okay, so in this way we can find the mean of discrete frequency distribution. Okay, here this is the similar type of formula with ungrouped data. Here what we need to do, sum of all the observation. Okay, but if some observation is repeated, okay, if some observation is repeating, then instead of addition we can do the multiplication. That means here 1 we have 5 times, so instead of addition we can directly multiply it. 5 1s are 5, that is one type of addition, right? Because multiplication means what? Repeated addition, right? So same thing we need to apply here. Now 2, it is 9 times, so instead of 9 times we need to add this 2, so instead of we can directly multiply it, 9 2s are 18, same way 3 4s are 12. So this is one type of addition of your all the observations. Okay, if you find this total, then definitely that is the total of all the observations. Alternately, both this formula are equal, only form is changed. Okay, here if some observations are repeating, then we do not add every time, but instead of that we just multiply it. Okay, now for discrete frequency distribution, if numbers are very large, so at that time, for simplicity, we can take one assume mean. Okay, that means shortcut method, and formula for mean x bar, it is equal to a plus sigma fd divided by n. Here instead of x we have d. Okay, so if x and f is given to you, then from the value of x, you can take one assume mean. Okay, one more thing. This A you need to assume in the column of X only. In the column of F, we cannot assume any A. Okay. So, for simplicity, if we take A is equals to 2, then here we need to put one column, D is equals to X minus A. Okay. Here we have value of X. So, from all the value, we need to subtract this value of A. That means 2. So, here we will get the column of D. After getting the column of D, we need to multiply F and D because that we want in our formula FD. So here we need to multiply this F and D. So we will get the column of FD. And if we do the sum of all this observation, then it is called sigma FD. Okay. Now here you can take any value of A. Okay. For A, that means assume min. It is not necessary that always we need to assume this value of A from the X only. You can take any value. But if you want to simplify this question, okay, if you want to do simple calculation here, so just take your assume min A is equals to the middle value of X. Okay, so that all the numbers becomes small and you can easily calculate it. Okay, so here if our numbers are very large, okay, and if we multiply large number with F and addition, then it is complicated. So for simplicity, we can take one assume min. Okay, so that is our A is equals to assume min, and from that we need to find this D. It is deviation. Okay, deviation of X from assume min. It is X minus A. That's why we put here subtraction sign. So first of all, we need to find this D, X minus A. Okay, after that we can make the column of D. After that we can find the FD, and that answer we need to put here. Okay, so min X bar is equals to A plus sigma FD divided by N. We can use any formula. Okay, if your numbers are very small, then directly we can use this method. If our numbers are very large, then we can use this method. Okay, then our next type of data, it is continuous frequency distribution. Okay, here continuous frequency distribution, in that some class is given to you. Here 0 to 5, 5 to 10, 10 to 15. In continuous frequency distribution, some class is given to you. Okay, now in that, how we can find the value of our mean? Okay, mean X bar. So first of all, here our formula is sum. Here our formula is sum sigma fx divided by n, which is similar with the discontinuous frequency distribution. But here class is given to you and frequency f is given to you. So how you can find the value of x? Now here x, that means midpoint, otherwise class marks. Okay, it is your midpoint. So how can you find the midpoint? Addition of this two number divided by 2. 0 plus 5, 5 by 2, 2.5. Similarly, 10 plus 5, 15 by 2, 7.5. 10 plus 15, 25 by 2, 12.5. Okay, so here first of all you need to find the value of midpoint. It is called x. So here now you have f, now you have x. So similar way you can find the mean. Okay, that means in next column you need to make here fx. And if we do the sum of all this observation, it is called sigma fx. From that we can get the value of sigma fx, and that value we need to put here. So mean x bar is equal to sigma fx divided by n. One more thing, here in both this case, n, our denominator n, that is means sum of all the observation, it is sigma f. Okay, it is sigma f. That means addition of all this frequency, it is called sigma f. Now why? Here 5, that means what? In 0 to 5 we have 5 numbers. In 5 to 10 we have 9 numbers. In 10 to 15 we have 4 numbers. So f represents the number of observation. Okay, if we total it, if we do the sum of all of this frequency, then it is the total number of observation, right? So this addition of f, that means sigma f, it is called our total number of observation n. Okay, Now here for shortcut we have one more formula for mean x bar. It is a plus sigma fu divided by n multiply c. Okay, a plus sigma fu divided by n multiply c. Here u means what? We already learned this method in standard 10, step deviation method, right? So this is the step deviation method. So here u means what? D minus a. First of all you need to find the d minus a. After that you need to divide it with c. Okay. First of all d minus a. Okay. Sorry, d minus a not, but here x minus a. That means our d. We can also write here d by c. Okay. First of all we need to find the d, that means x minus a here. Okay. After that, if our answer of d it is even large. Okay, here first of all we need to see if our answers of class is very large, then what we need to do, d is equals to x minus a. Okay, if still our answer of d is very large, at that time we can use this step deviation method. We can take u, that means d by c. Okay, first of all again I repeat this thing. First of all, if class are very large, at that time we need to use deviation method, that means this d, x minus a. If still our answer of d is even large, at that time we can use the method step deviation. Okay, and here in denominator c, c that means what? Common factor. In standard 10 you take here it's a class length, right? But it is always not necessary. Okay, here c means not class length, but it is common factor. Okay, in standard 10 even, that h, you in place of c you will take a h, right? You already taken h here, so that h is not your class length, but it is common factor. Okay, in standard 10 in all the questions class length of all the class are same, right? In standard 10 whatever sum is given to you, in that in one question for all the class length are same. But if class length are not same, then you cannot take here h. Sorry, you cannot take here class length. Okay, in this standard, that means in standard 11 even, if class length are same in all the class, at that time we just take c is equals to our class length. Okay, again I repeat these things. If class length are same in all the class, at that time we use c is equals to class length. But if our class length is not same, then here we need to use common factor in d, that means x minus a. We need to check the column of d. Okay, if any common factor are there, so that we can take as c. Okay, alternately, if class length is not same, then we do not use this method. Okay, if class length is not same, then we do not use the step deviation method. We can use the deviation method. That means d is equals to x minus a. We cannot divide it with the c. Okay. So alternately, if our numbers are very small, then direct method we use. If our numbers are big and class length are same, then we can use the step deviation method. If our numbers are very large but class length is not same, then we need to use deviation method. Okay, these things we learn in the exercise. Okay. Now, here our next topic for the mean. It is combined mean. Okay, this is new for you. Combined mean. That means more than one mean are given to you. Then how can you find the combined mean? So formula is n1 x1 bar plus n2 x2 bar up to the nk xk bar divided by n1 plus n2 up to the nk. Okay, this is combined mean. It means some more than one mean are given to you. Okay, and for all the mean, number of observation is given to you, then you can find the combined mean by using this formula. Okay, here this is the similar type formula with this. Here what is it? Sigma x by n. Now if you look for the n1 into x1 bar, okay, x1 bar is equals to sigma x1 divided by n1, right? This is the formula. x1 bar is equal to sigma x1 divided by n1. Now transfer this n1 to the left hand side. Now transfer this n1 to the left hand side. So here n1 x1 bar is equal to sigma x1, right? n1 x1 bar is equal to sigma x1. Okay, so n1 x1 bar, it is sigma x1. That means here we have sigma x1, sigma x2 and sigma xk. That means sum of all the observation, right? Here n1 x1, that means sum of observation sigma x that we want in the numerator, right? Here what we want, sigma x, and that we get here by multiplication of n1 into x1 bar. So it is sigma x1, right? So this is sigma x1, sigma x2, sigma xk. That means in numerator we have sum of all the observations. Okay, in denominator what we want? Total number of observation, right? So total number of observation in case 1, total number of observation in case 2, total number of observation in case k. That means the total number of observation, right? We have lots of data here. So first of all, in each data we find the sum of observation and we add it. So in numerator we have sum of all the observations. In denominator we have more than one data, and for each data we have different types with different number of observation. Okay, so all the observation we add here. So alternately this is the similar formula. Okay, for combined mean, n1 x1 bar into plus x n2 x2 bar up to the nk xk bar divided by n1 plus n2 up to the nk. This is combined mean. In same way we have weighted mean. Okay, this is combined mean xc, c for combined, and this is weighted mean xw bar. Okay, if weightage is given to you, then in place of n you need to write w, weightage. Okay, for weighted mean what we need to do? In place of this n we need to write w. So here n1 x1 bar, here w1 x1. Okay, here bar is not there, only w1 into x1. Same way w2 x2, wk. Here we use n. Okay, so w1 xn. And in denominator here n1 plus n2 up to nk. Same way w1 plus w2 up to the wn. Okay, in place of n1 here w1, in place of x1 bar only x1 is there. Okay, this is the similar type of mean. And when we use this weighted mean or combined mean, if in the equation weightage is given to you, w is given to you, at that time only you need to use this formula. Okay, in the equation if w is given to you, at that time only we need to use this formula. Okay, then this is our arithmetic mean. Arithmetic means what? What is the basic arithmetic process? Addition, subtraction, multiply, division, right? So by using the addition, subtraction, multiply, division, if we find the mean, it is called arithmetic mean. Okay, but in geometric mean we need to take nth root. Okay, here arithmetic mean is represented by x bar, geometric mean is represented by g. Okay, arithmetic mean is represented by x bar, geometric mean is represented by g. Okay, so here g is equal to nth root of x1 x2 up to the xn. That means if you have 4 observations, right? Let's suppose 1 2 3 4. If you have 4 observations, then you need to multiply it. Okay, now how many total number of observations you have? 4. So here you need to take 4th root. Here it is written n. So if you have 4 number, then here you need to take 4th root. If you have 3 number, so here you need to take cube root. Okay, if here you have only 2 numbers, then you need to take square root. Okay, this is not a multiplication n. This shows the nth root. If 10 numbers you have, then you need to take the 10th root of product of all your observation. Okay, here we need to take nth root of product of all the observation. If you have 15th 15 observation, then here we need to take 15th root. Okay, whatever number of observation we have, we need to multiply it and we need to take nth root. Okay, this is geometric mean. Okay, and one common thing, it is x bar is always greater than or equal to geometric mean. Okay, geometric mean is always less than the arithmetic mean, otherwise both are equal. Okay, so x bar, that means arithmetic mean, is always greater than or equal to this geometric mean g. Okay,